This is section 410 for Acids and Bases unit of Chemistry 12. Topic is relative strengths and predicting the direction of an equilibrium. So you use the stronger acid to predict the direction of an equilibrium. In a Bronsted-Lowry equilibrium, there is an acid and a base on both sides of your equation. So how would you know which direction the reaction will proceed? Another way to ask this is to ask which side is favored. To solve for this problem, you will look at the two acids in the equilibrium. So in this question, which way will the reaction proceed? I'm going to circle both of my acids, one on each side. This equilibrium had already been completed for me, and I did not have to decide the acid and the base. So you're going to look up both of these on your acid-base table. So I'll go over to my table, pause here if you need to get your table. And you will see that H2PO4 minus is 6.2 times 10 to the minus 8 for a Ka, and HCO3 is 5.6 times 10 to the minus 11. So I'm going to put those into my question here. I've looked up my Ka values and I've decided that this one is the stronger acid. Instead of using the number, you can also determine the stronger acid by which one is higher up on the acid side. Once you know that in this case H2PO4 is stronger, here's the explanation for why the reaction will proceed toward the products. The reaction that is stronger ionizes more and has a greater tendency to donate H+. So my forward direction of my reaction is represented by this large purple arrow. It has the bigger equilibrium arrow than my reverse direction. My reverse direction is HCO3. It's got a smaller arrow. So in the end, my reaction is going to proceed toward my products, and my products will be favored. The shorthand way to memorize this for Chemistry 12 is to memorize that you are always going to shift away from the stronger acid. Okay, my example number 1 here asks us to predict whether reactants or products will be favored when HCN reacts with HCO3. So first of all, I haven't had my ending written for me, so I have to do that first. So I need to look at my reactants and see that both of them can donate an H. I have an H here and an H here. So that doesn't help me right away, but I can recognize that HCN absolutely cannot accept an acid, so it has to be the acid. Sorry, it cannot accept an H+. So if it can't accept an H, it's going to definitely act as the acid, which would make HCO3 minus my base in this case. I'll complete my equation by donating my proton. Do a different color. Cn minus will be my conjugate base. H2CO3 will be my conjugate acid, and that should not have a minus sign. There we go. So then our next step is to look up the Ka of both acids. So I'm going to be looking for this one here, and on this side it is HCN. So to do that, we're just going to go to our acid-base table. I've done one on the side here where I've highlighted them. I've looked them both up. I have found my HCN, and I found my HCO3. And from that, I can tell that my HCN is the stronger acid because it is higher up the table. Okay, so our next step, determine which acid is stronger. It is HCN. And then the direction will be away from the stronger acid. So if I go back up to my equilibrium, HCN is here, which means my entire equilibrium will proceed this way. So in that case, it's going this direction, or if you are answering in words, you could say that it's going toward products or products favored. Okay, my example number 2 asks what happens when we have two amphiprotic ions, so HCO3 minus and HS mixed together. So these are the two I'm starting with. My ending has not been written, so I need to start by looking for HCO3 and HS on the acid side. So when we do this, we find that only HCO3 is on the acid side, but no HS. So I'm just going to show you on my table. Follow my highlighting line down. In yellow, I have HCO3, but I have no HS. So I can't compare them because they're not on the same side. So what I do next is I go to my base side. So when I go to my base side, I'm going to look up both of them as bases. And highlighted here, I have found that HCO3 and HS are both on the base side, so that means I can compare them. Remembering that the strength of the base goes down the table toward the strong, I know that my HS is a stronger base, which means my HCO3 will act as the acid in this question. So now that I know which one's going to be my acid, I'm going to go back to my question. And we're going to write the ending of our equation. So I just determined that HCO3 would be the acid by looking at my table, which makes HS the base. I'm going to donate my proton this way, so I will have CO3 minus as my conjugate base, and H2S as my conjugate acid. Okay, and then again, we're going to go back to the table a second time. So now I have to look up the two acids. So when you're doing an amphiprotic ion, you're going to the table a second time if it's amphiprotic. Once in the first step to figure out who's going to be the acid, and then again to figure out the answer. So I'm just going to scroll down. And the two that I am looking for, I've switched to pink here. I'm looking for H2S, which is right here, and HCO3, and I can see that H2S is my stronger acid. So I'm going to come back to my answer. We see that H2S is stronger. Okay, and if we're going away from the stronger acid, this time we're actually going this way because HS is on the product side, which means this reaction will favor reactants. Because my stronger acid is a product, and the rule is I'm going to shift away from my stronger acid. Okay, and my very last example, I've done step 1 and step 2 for you. You should pause here and see if you can answer yourself. Otherwise, I'll go through my 2 steps with you. The first step I've completed in red, so it's asking whether reactants or products will be favored. These are both amphiprotic. So step 1, I'm going to go over to my table, and I'm going to decide which of HSO4 and HC2O4 minus is stronger. So I have to reuse this table I've used already. So I have HSO4 right there. And there's H2, but that's not the ion I want, so I'm going to go down a little farther. Here it is, HC2O4, and I can see that HSO4 is stronger. So my first step is I have found that HSO4 was my stronger acid. I have donated its proton away, and now I'm going to look up my 2 acids that I have circled in, oops, I wanted to say yellow highlighter. There we go. And again, I'm going to go back to the table a second time, because if it's amphiprotic, you're going to look them up twice, and we're going to find one of them, HSO4, I've already looked up. The other one, H2CO4, has now moved above it. That guy's definitely stronger. And I've noted here that step 2, this one is my stronger acid. It will proceed away from the strong acid, which means toward reactants in this case. And you are now ready to complete worksheet 4.10, relative strengths of acids and bases.